we have this same exact graph. We're going to have a different interval we're looking at. So 1/2 to the x. Now I want to get to the interval from 2 to 4. So on my graph, right? So from here to here. In this little window of time, what is the graph doing? Okay. Again, I need to make sure that I have 4 in my table. So I'm just going to work backwards. 4. 4. 3, 2, 1, 0, -1. Okay. I want to plug that in from my table. I get, again, 2, 1, 1/2, 1/4. This one's getting small. 1/4, 1/8, and 1/16. Okay, again, don't be afraid of fractions. Alright? And the question is, on the interval from, so 2 is my x, and to 4 is my x. So from this interval of time, what's going on? What's the rate of change? So we can go ahead and graph. Remember, my horizontal asymptote is going to be y = 0. And I'm just going to go ahead and start graphing. So -1, 2, -1, 2, 0, 1, 1, 1/2, 1/4. It gets closer and closer and closer, but never actually touches that asymptote. And then, so we know the general shape over here. Alright. And now the question is the rate of change. I'm going to do this one over to the right. So, remember my slope formula is y2 minus y1 over x2 minus x1. And we're going to use the coordinates 2, 1/4. And 4, 1/16. Alright. And from here, let's go ahead and label. So we have x1, y1, x2, y2, and we're going to plug it in. So m equals 1/16 minus 1/4 over x2 is 4 minus x1 is 2. Okay, and again, just focus on how you plug in the calculator. Use those fraction buttons. 1/16 minus fraction 1/4 over 4 minus 2. And when you do this with me, you should get -3 over 32. Okay? And that's my rate of change over that interval. Okay? And nope, I don't want to stop, sorry. The last step here, again, in behavior, should end up being the same, but let's talk through it again. So, as x approaches -infinity, so as this graph goes to the left, what are my y's doing? Well, they're going up and up and up until they hit infinity. But as x goes to positive infinity, to the right, this graph is getting closer and closer in the y direction to that asymptote of 0. Alright? Now, if you want to take a look at the big picture here, alright, big picture, let's look at these rate of changes. Notice, we had the exact same graph. 1/2 to the x, 1/2 to the x, 1/2 to the x. Same exact graph. But we had 3 different rate of changes. We had -6. We had -5 over 4. We had -3 over 32. So the highest rate of change, forget about the negatives for a second, right? Highest rate of change is on the left, this -6, or 6. Right, it's dropping the quickest in that little window. Okay? Then number 29, it's dropping a little bit slower. And then on number 30, we're at that really evening out part. So it's going to be a really, really small slope. All right. Now, this is the same graph, different rate of changes all the way across. Very different from our linear unit where the rate of change was always the same. All right. So, pause this video as needed. Take your time. You need to do number 31, 32, and 33, focusing on that same exact process we just did. Build the tables, find the rate of change on that interval, and give me the end behaviors. All right, you can check your answers on my blog. Day 5 in the books. Have a wonderful weekend. Get some rest, rejuvenate, and we'll get back at it on Monday. All right.